In this video, we are going to discuss about xenon compounds. Xenon, it belongs to noble gases. In other words, it is inert gas. The inert gases are helium, neon, argon, krypton, and xenon. They are known as inert because they won't react readily. So they are highly inert compared to other elements. Since the p orbital is completely filled, it will not undergo reaction easily. So we call them as inert gases. In this, these four, they are very less reactive. Sorry, it is xenon, not Ze, it is Xe. So the number of compounds with these noble gases is very less. On the other hand, if you go for xenon, there are so many compounds based on this. The most common one are xenon fluorides. It may be XeF2 or XeF4 or XeF6. How do we synthesize them? It is very simple. Take xenon, add fluorine. If you add 1 equivalent, you will get this. With 2 equivalent, you will get this. With 3 equivalent, you will get this. But XeF8 is not available. So even though there are 8 electrons in the outermost shell of xenon, XeF8 it is not possible to get. So we have XeF2, F4 and F6. So these are fluorine compounds. Based on that, you may be asked to find out the hybridization in this compound. What is the geometry or shape? Last one, what is the point group of these compounds? For hybridization, you have to go for which group it belongs to. It belongs to 8th group, and how many lone pairs and how many bond pairs are there. That you have to consider. So I go for one molecule, the remaining you can try. This is p orbital. This s orbital. So basically, see, this is d orbital. Goes further, there will be 5 suborbitals in that. I have excited one electron from this to here, so that I can form 2 bonds with fluorine atom. This molecule has 3 lone pair and 2 bond pair, so total 5. So it should be sp3d. If you go for this, I have to go for one more electron excitation. What I get is sp3d2. The next one, it will be sp3d3. So you can easily predict. Then what will be the structure? Totally there are 5. In that 3 lone pair and 2 bond pair. So it will be trigonal. Sorry, it will be linear. Something like this. There will be 3 lone pairs like this. If you consider only this xenon and bond, it will be linear. So that is shape. If you go for geometry, it is trigonal bipyramidal. What about this? When you go for sp3d2, there will be 2 lone pair and 4 bond pair. So total 6. That is nothing but octahedral geometry. It will be something like this. There will be lone pair here, and 4 fluorine atom in a plane. The next one, it is XeF6. So in that there will be only one lone pair and 6 bond pair. So this is something different. The most accepted geometry, it is distorted octahedral. One may expect pentagonal pyramidal shape. At bottom there is one lone pair. So basically it is pentagonal bipyramidal. In that I have placed one lone pair. But compared to this is the most accepted one. Distorted octahedral. Now let's go to the point group. It is very simple. It is linear molecule similar to carbon dioxide. The point group will be D infinity H. So this one, it is planar molecule. It is similar to platinum tetrachloride. So it is a square planar complex. For that it will be D4H. So this is distorted octahedral. So we don't go for the point group. Since it is distorted, the symmetry is lost. It won't be octahedral. At the same time, the symmetry of this is very less. Now, in addition to that, we have few more compounds of xenon, that is XeO, F4, XeO2, F2 and XeO3. So what I have done is, I have replaced 2 fluorine atom by 1 oxygen, 4 fluorine atom by 2 oxygen, 6 fluorine atom by 3 oxygen. In this particular xenon trioxide, it is explosive. How to prepare them? It is very simple. Take XeF6 and add water. What you get is 1 oxygen replaces 2 fluorine, you will get HF and this one. If you add more water, then you will get this. If you add more, you will get XeO3. But the problem is, if you add more water, then you may end up with xenon trioxide, which is explosive. So generally explosive reaction is not preferred in lab. So what they do, they go for very small quantity of water. They try to convert this into this. From this they convert to this using some other reagent. What they use is trifluorophosphine oxide. This oxygen can be transferred to xenon. So this acts as oxidant and donates the oxygen. Not only this, even nitrate. This nitrate can oxidize xenon fluoride to this. Now again they may go for hybridization. What is the geometry and what is the point group? So I give this as a practice problem. Try to find out what will be the geometry, what will be the shape and what will be the point group for these 3 compounds. I go for geometry, then it may be somewhat easy. So this will be square pyramidal. So you can predict the point group. This one, it will be T shape. What about this? This will be trigonal pyramidal. So it will be somewhat easy to predict the point group based on this. This will be C3V, C4V, this C2V. Hybridization you can calculate easily. Try to practice.